In Module 2, you will begin to learn processes that would help your organization meet regulatory compliance requirements. First, the team will explain the components of client system administration. What is a client as it relates to systems? What is endpoint protection and some best practices to keep your systems safe? And how patches fix vulnerabilities. Finally, you will explore how to devise a patching process to protect against threats. Let's begin. In this video, you will learn to define a client as it relates to a computer system, define the characteristics of client system administration, describe why effective client system administration is important to cybersecurity.
Hi there. Today we're going to talk about client system administration. And when we talk about a client, it really is in the context of a client accessing a server. So a client will be anything that really accesses a server application, like a web server, a mail server, or a file server. And a client can be anything like a desktop computer, a laptop, tablet, and even smartphones. Anything that is used to access resources that sit on a server is really considered a client from an IT perspective. And a single server can really have many clients that talk to it, and many clients can access that one server at one time. So it's not a one-to-one relationship. It's typically a many-to-one server relationship, and one client can also access multiple servers that have different purposes. So for the purpose of this discussion, that's really what we're talking to when we talk about a client. It's any system that will access resources on a server. So when we talk about the context of client system administration and cybersecurity, we're really looking at it in a couple different ways. And you're all going to be familiar with cloud and mobile computing. We all have our smartphones that we access apps, and most of those apps will operate in a typical client-server methodology where the app is actually accessing some kind of server resources that are hosted somewhere else, typically in the cloud on an AWS or an Azure or an IBM cloud or any of the other myriad of cloud hosting providers that there are. New devices and new applications and new services are coming into organizations all the time as people load applications, as new line of business applications are coming online. It's really an on-demand kind of world that we live in, and that leads to lots of potential threats that could be present as those new applications come online. And really, endpoint devices are the front line of attack. That's how most bad actors or hackers will try to get into an organization, is by accessing an endpoint or a client and then branching out from there. So malware will be installed based on a website that someone goes to, or a phishing attack, or a spear phishing attack, or ransomware. Any of those kind of attacks can lead to large problems within an organization. Let's talk a little bit about the common types of endpoint attacks, and this is just a very small list. There are lots of endpoint attacks, but phishing or spear phishing is an email which imitates a trusted source designed to target a specific person. That's spear phishing. So think of a spear as in a very sharp point, and that sharp point refers to the specific person that you're trying to attack. I've also heard the term whale hunting, where a person will try to attack a very specific person in an organization, like a C-level executive, and that's what we refer to when we talk about whale hunting. When we're talking about a spear phishing attack versus just a normal phishing attack, spear phishing is going after a particular particular person in an organization, again, that pointed attack, or a specific department, versus a phishing attack, which is a mass email that would go out to everybody within an organization, and anybody who clicks on it would be the target of that attack. A watering hole is malware that would be placed on a site frequently visited by an employee or a group of employees. So, we're trying to just get anybody who would would go to that site. They click on a bad link that installs some malware on the endpoint, and then I'm in the organization and can branch out from there and try to get the information that I want. And then these ad network attacks, so using ad networks to place malware on a machine through ad software. So I click on a link on a website that again goes to download some malware on an endpoint, and then again I'm in the organization to do whatever activity I want, install malware, install ransomware. We've all heard about these ransomware attacks that are focusing on public sector entities. Like the city of Atlanta had a very large one last year. The city of Lake Florida had one earlier this year. So they're becoming much more prevalent and really are becoming a big deal for organizations. Island hopping is a supply chain infiltration. I'm really not as familiar as that with as I am with some of the other ones, but I'm assuming that would be where we try to infiltrate someone's supply chain to disrupt business operations or to get information about the organization's supply chain in order to cause problems or to get information that we could potentially sell. And really, when we're talking about endpoint attacks and malware, the whole goal of this is to make money, right? I mean, whether it is to disrupt a competitor's business operations, or it's to directly blackmail the company to get money from them to not release that information or to decrypt information that we've encrypted through the malware, and that's really what ransomware is. But the whole goal of this is to make money. That's why people do it. It used to be, when you talked about hacking, when we talk about movies, and I'm going to date myself here, like war games, it was just to get in to see if I could get something. Now what we're seeing are organized attacks to specific organizations for the sole purpose of getting money from that organization, either in the form of disrupting their business activities, or a direct, you pay me and I'll give you back your information. So that's really what we're seeing in the threat landscape when organizations are trying to hack other organizations and disrupt their business activities.
In this video, you will learn to define endpoint protection, describe the basics of endpoint protection.
So let's talk a little bit about how we protect from those attacks. So when we talk about endpoint protection, it's really a policy-based approach to network security, because we're really securing the network to prevent the endpoints from being attacked, or to minimize the number of attacks that are going against our endpoints, and we do that through network protection. So network policy, network security, it really requires that endpoint devices comply with specific criteria before they're granted access to network resources. So those endpoint resources need to be at a particular patch level. They need to have specific software installed, such as antivirus and endpoint detection and response software. Each organization is different in what they require for endpoints to be installed in order for them to access network resources. But it is a policy-based approach, and typically the security organization within a company or public entity will establish those policies in order to best protect the network and therefore endpoints from being infiltrated. Endpoint security management systems are typically a software or a dedicated appliance, and they discover, manage, and control those computing devices that request access to the corporate network. So really what that means in layman's terms are the security management systems are tools that help on a mass scale protect your endpoint. So it's things like antivirus, it's things like patching solutions so that we can en masse patch endpoints and bring them up to the current level to reduce vulnerabilities. It's anything that protects the endpoint that is managed by the company's IT organization. And endpoint security systems typically work in a client-server model. So you'd have a centrally managed server or centrally managed appliance that would provide that policy to the endpoints in the organization that we're protecting. So like I said, it could be an antivirus, it could be an EDR solution, but all of those solutions are going to have an application that typically resides on the endpoint or an agent that resides on the endpoint, and then that is centrally managed either through some kind of website or a console application, any way that I can centrally manage and see all the endpoints in my environment to manage them and to provide protection around them to minimize hacks and minimize infiltration into the system and to prevent those bad actors. So one of the concepts that has really gotten a lot of press lately is the concept of unified endpoint management. As we continue to broaden how we're accessing resources on the network, things like smartphones and tablets and laptops and desktops, we want to have a single pane of glass, if you will, in which we can see all of our devices. And that's really what unified endpoint management is all about. It's a platform that would converge traditional client management techniques like a Big Fix or like a SCCM or any of the solutions that are out on the market and combine those with what we call an MDM application. MDM stands for Mobile Device Management, and typically manufacturers of your mobile devices like Apple and Android, the two largest ones, will provide APIs, which are what are called application programming interfaces, so APIs into the operating system so that I can protect them. And the unified endpoint management solution will combine those traditional client-server management techniques with those MDM APIs so that I can manage my entire environment. Mobile device management or enterprise mobile management, both terms can be used, really provide solution around mobile devices, but not so much around typical client-server devices. Now, that being said, newer operating systems like Mac OS and Windows 10 do have some MDM APIs built in. So many MDM providers like IBM's Mass 360, like AirWatch and Mobile Iron will have some capability to manage both traditional MDM applications, so they manage typical mobile devices like Apple and Android, as well as some management capabilities around Windows 10 and Mac devices. But a true unified endpoint management platform would be able to manage all of the resources in your environment, not only mobile devices, but also endpoints like desktops and laptops, as well as servers, Unix devices, Linux devices, and that's really what we're talking about when we talk about MDM, is the convergence of all those management platforms into a single pane of glass, if you will.
In this video, you will learn to describe how endpoint protection works, describe an example of endpoint protection.
So let's talk about endpoint detection and response. So endpoint detection and response, or EDR, is kind of a newer term that has come up. It is protecting the endpoint and responding to attacks in addition to or on top of more traditional antivirus solutions. So you're probably familiar with antivirus and how that works and the things that we're trying to protect on a specific endpoint and prevent viruses from causing problems to the endpoint. But EDR goes a step further than that. So it has some capabilities associated with it, which are deploying devices with network configurations. It will also do things like automatically quarantine or block non-compliant endpoints. So if my EDR solution sees that I don't have a particular patch level or I don't have particular software installed, then that EDR solution would block me from being able to get to anything on the network, on the corporate network, until I get to that patch level or get the requirements, or I should say the prerequisites that are needed in order for me to do that. And typically when we quarantine an endpoint, the only thing that we're going to get access to is the actual EDR solution for those patches or those applications to be downloaded and put on that endpoint in order to make it compliant with policy. It will also have the ability to manage lots of devices at once. So my EDR solution will have the ability to distribute patches to all of the endpoints in my environment so that I can keep them compliant and give them the requirements they need to access resources on my network. Endpoint detection and response has those kind of things we talked about before, like automatic policy creation for endpoints, so I can create policies that will tell me what the requirements are or set the requirements are for endpoints to access things on the network. They will also be able to do things like zero-day OS updates. You've probably heard of zero-day vulnerabilities where there weren't really any heads up to those vulnerabilities, and they're very quickly patched and remediated by an EDR solution. And then it provides also continuous monitoring and patching as well as enforcement of security policies across all the endpoints in my environment. So it's giving me that ability to manage every device in the environment in order to keep them up to date and minimize the vulnerabilities that can be exploited by someone who wants to get in my network. So when you're talking about an endpoint security solution, there really are several facts to consider when we're evaluating them. One is threat hunting, my ability to go and see what threats are present in my network and minimize them, or find out what happened when a threat has been detected and do some investigation around that. How am I going to respond once I've found a threat? So am I going to quarantine? Am I going to segregate that machine from the rest of the network? What am I going to do to investigate to minimize what's going to happen to the rest of the environment when I do find something that's going on? So how am I going to respond to that? And then also user education is really important. What you'll find is that about 50% of events, security events, are actually insider events. And when we say an insider event, it doesn't necessarily mean that it was malicious. It could be an accident, but it was caused by an employee going to a bad website or clicking on a link in a phishing attack or some other way that I have been infiltrated, and it was through an employee's ignorance or malicious behavior. Like I said, it doesn't necessarily have to be malicious behavior, although that is something to think about. So user education is really important because of the amount of threats.
My name is Matthew Shaver, Knowledge and Content Manager here at IBM, and today I'm going to be talking a little bit about Unified Endpoint Management, or UEM, what it is, and where it fits into the modern enterprise ecosystem. While device management is not a new idea, it has evolved quite a bit over the past decade or so to reach the point that we are now at, called Unified Endpoint Management. Traditional mobile device management solutions were built for a simpler time. Relatively straightforward. When smartphones hit the market, there was this really loose set of APIs that could be used, and their impact on the device could be critical, but the number of them was relatively few. For example, wiping a device was a pretty standard idea. If an organization felt that there was a security breach, they could do so through an MDM solution or even via an ActiveSync command from the mail server. BlackBerry came along in the flip phone era and brought this idea of enterprise management over mobile devices, specifically mobile phones, that would be leveraged in the enterprise. It consisted of an on-premise solution that was placed into the environment and could speak directly to the BlackBerry devices. However, when we started to get more and more device types out there, namely iOS and Android, there became a need for a kind of centralized management solution that could handle everything. And that's when MDM solutions started popping up, such as Mass 360. And they could handle these devices through APIs that were embedded in the actual operating system. Well, as time went on, there was an increasing demand to be able to manage all devices under a single umbrella, no matter what they were, whether a desktop, laptop, smartphone, or tablet. So where unified endpoint management really starts, the foundations of it are the devices themselves and now Internet of Things. So smartphones and tablets, PC desktops and laptops and servers, smart connectivity devices. It's not just the devices that need to be secured, however. There's a lot of content floating on around there. It's not only important that we secure existing enterprise content, but that we be able to separate it from the personal data and remove it if necessary without impacting any of that user's personal information. The next layer is the people and identity, the people that handle the devices themselves and what they use to authenticate into these various systems that are supported on mobile devices. So all of these layers really come together as unified endpoint management. What does this journey look like? So we have the devices, the things, the apps and the content, the people and the identity. Well, let's say I come into a new organization and I have my personal smartphone with me. When I start my job, they issue me a company-owned laptop. Via these systems, I get my devices enrolled. One is marked specifically as BYOD, the other is marked as a corporate-owned asset. And because of that, different compliance rules are held over these devices, different sets of monitoring, different actions will be taken if I fall out of step with the enterprise guidelines. Not only that, but now I can receive corporate apps and content on my personal mobile device, and the company retains the ability to remove just those apps and just that content without impacting any of my personal features. And in order to get enrolled in all of this, I am provided a set of credentials by the company that syncs across these platforms. So I have the potential to enter credentials just one time on my mobile device, and that not only enrolls it within the Mass 360 solution, but also pushes down all of my email configurations, corporate document access, intranet resources, without me having to authenticate subsequent times. And of course, management is crucial to all of this, but also insight, being able to see into my environment, understand what's out there, understand where threats might lie. What happened, what can happen, and what should be done if something happens. So the policy engine, the compliance engine, and device monitoring, things like malware, antivirus, are all encapsulated by this unified endpoint management in the context of this environment. Taking a new approach, going from digging through old news articles and blogs randomly, scouring Twitter, trying to find out the newest threats that are on the market, to being proactively alerted on this information, asking questions and getting answers is becoming more and more important. So unified endpoint management isn't just about giving you a platform to manage devices, but also educating you on what is out there in the market. Getting knowledge directly to the admins that are managing these devices on a daily basis, as well as the end users. Understand that best practices can change across verticals and even depending on the specific devices you're deploying, as well as company size. So there isn't a general set of best practices that works for everybody. We can make recommendations, but those recommendations are much better if they're suited to your environment. Developing an action plan can also be replaced with taking immediate action within context. If a threat hits the market that impacts the devices inside your environment, you don't want to have to go through weeks and weeks of meetings to decide how to resolve it. You want immediate action. Unified endpoint management can take that action for you. A lot of this comes through admin setup. At the very top of our pyramid here is cognitive. Mass 360 with Watson, that's our cognitive piece here, provides a trusted advisor, augmented intelligence and cognitive computing. What this means is that we can provide you with automatic, actionable insights and contextual analytics. We can show you app ratings to understand that if an application is on the market, just because it's passed the Play Store or the iTunes Store security checks doesn't mean it's 100% right to be inside your environment. So app ratings, contextual analytics can provide additional insights there. We can also group devices together automatically as new threats hit the market. If there is a security vulnerability in a particular version of an operating system, Watson Insights can gather those devices into a group, set them up for you, and display them so that admins are aware of it, and provide you with a method to provide automatic action over those devices, whether it's a simple removing them from the environment or something more stringent like a complete wipe of the device. And on top of this, again, we can provide the apps, the content, and the data, the people, and the identity security to connect these devices, as well as the devices themselves. 3 trends reshaping mobility: platform convergence, the Internet of Things, and identity management to bring this idea of unified endpoint management to a close. Traditional clients had agent-based approaches. Install an agent, that takes over device management. Installs patches, takes care of maintenance. Rinse and repeat process. New device, new employee. IT admin takes it, images it, and provides it to the employee. Mobile device management was an API-based approach. The solution is already embedded in the device. You just need a certificate or an agent installed to unlock those capabilities and manage them. Security and management of corporate mobile assets also became important. Containerized doc retainers, email, secure access to information that can be removed without impacting the user's personal assets. Specialized for over-the-air configuration. You don't have to be hands-on with these devices. There's deployment programs so you can ship them directly to your users, and they will be forced to enroll them before they can ever get started working on the device. So modern unified endpoint management brings all of these ideas together under a single umbrella. Traditional client management and MDM APIs, sometimes working together on the very same device, but covering all the major platforms that are out there today. So there we have it. That's the basics of unified endpoint management. Device management, client management coming together, one team, one solution, all devices, UEM, or unified endpoint management.
In this video, you will learn to define patching, describe why patching is important to avoid cybersecurity threats.
Now what we're going to talk about is patching, and patching is really important regardless of the operating system you're talking about. You know, we hear about Windows patches because most of us use a Windows PC, and we see that little notification in the right lower corner of our screen that says, "Hey, your machine needs to be rebooted. We've installed some patches, and we can't make them effective until you reboot your computer." But patching is really the same regardless of what the operating system is, and it's really important, and frankly, the fundamental and most important thing that an organization can do in order to protect itself from malicious events occurring. We've all heard the news about how companies got hacked. We've all heard the news about ransomware. There's lots of examples in the U.S. of public institutions like cities, the city of Atlanta, the city of Baltimore, city of Lake City, Florida are recent ones that I can recall where they were subject to ransomware. They were asked to pay a ransom, and when we talk about ransomware, it is somehow somebody gets into the system, and it's usually a foreign entity, and they will put some code on there that essentially will encrypt everything on that hard drive. And that will propagate to all the machines in the environment, rendering basically all of those files and folders useless unless you pay a ransom, hence the name ransomware. And that ransom is usually in the form of Bitcoin. And once that ransom has been delivered, then you will be given the key to unencrypt all your files and get your files back. Now, the folks who have paid are very successful in getting their files back, but many organizations and municipalities have said, no, we're not going to pay, and they've spent much more than the ransom on the cost of recovering those files. So the net of it is it's just really important to patch and to keep your systems up to date. And I went off on a little tangent there, but I think that's just important to talk about a real-world example. So when we talk about patching, and as I said before, this is whether you're talking about a Mac, whether you're talking about a Windows system, and whether you're talking about a Linux or a Unix system, patching is really the same from the concept of why we do it. The mechanisms of how we do it may be a little bit different depending on the operating system, but why we do it is the same. And a patch is really just a set of changes to a computer program or it's supporting data designed to update, fix, or improve it. improve it. Excuse me. This includes things like security vulnerabilities, other bugs, and that's why some patches might be called bug fixes. But we also, when we talk about patching, talk about patching the operating system.
In this video, you will learn to describe how patching works, describe patch management best practices.
So in the context of Windows, Windows Update, which we're all probably pretty familiar with, allows to fix known flaws within Microsoft products and the operating systems. There are modifications to software and sometimes hardware, because you may have hardware drivers that have a vulnerability in them, and they help improve performance, reliability, and most importantly, security around that system. Microsoft, and we're, like I said, we're just using the concept of the context of Microsoft because that's what everyone's most familiar with. They release their patches in a monthly cycle, and most people in the industry call that Patch Tuesday because they do. Microsoft releases its patches the second Tuesday of every month on Patch Tuesday. And there are really 4 types of updates for Windows OSs, but these are also the same across other OSs, Linux and Mac as well. And those are security updates, which are really probably the most important updates, and many organizations will not deploy patches other than security updates. They feel that application updates and going to a newer version of a particular version of Microsoft Office just to expand features don't really make a lot of sense. We're mostly concerned about security updates that patch vulnerabilities in the operating system. Those security updates are classified as critical, important, moderate, low, or they may not even be rated because they're not viewed as important. And many organizations will only patch critical and important security updates. So it just depends on the organization and what their philosophy is around patching. Because sometimes, and this is not always the case, but sometimes a patch may cause issues within other applications that are needed to do the organization's business, and that's why they choose not to patch everything. So there's a lot of testing that goes into place with patching within a large organization or even small organizations, because we need to make sure that the patches that are released will be compatible with our environment. And that's why patching, even in 2019, is still a big challenge. I've been focusing on patching for the majority of my career, so everybody has said for the last 20 years, patching is basic stuff and isn't important. Well, it's important, and we find that it is actually more and more important as cybersecurity events continue to occur. Second kind of updates are critical updates. These are high priority updates that may not be security updates. So they may not be classified as a security update, but they are still considered critical. There may be a bug in an application that causes something, and that critical update needs to be applied. So as I mentioned before, many organizations will only apply security updates and critical updates to the operating system, and then they just don't worry about the other ones because they don't want to test for compatibility. Software updates, which are released by Microsoft, are not considered critical. They are things like feature upgrades or reliability upgrades of a particular software that don't have to do with a vulnerability. So if say Microsoft Office crashes every month and a half, if I'm doing something very odd and they release an update to that, that's not as important as a security update, because that's not something that can be exploited by a bad actor. And then there are things like service packs. Service packs are roll-ups or a compilation of all the previous updates to ensure that you're up to date on all the patches. They also may include feature updates or feature enhancements to the operating system, but typically a service pack is a roll-up. With the way that Microsoft has kind of changed their patching and their update strategy, service packs are probably going to be a thing of the past. If you talk about, say, Windows 10, Microsoft has kind of placed a stake in the ground and said Windows 10 is going to be our only operating system. We're just going to add functionality onto that, and then so service packs are really not something that is really as important as it used to be. So let's also talk about patching applications. And again, when we're talking about applications, it doesn't matter whether we're talking about Windows or we're talking about Linux or Unix or Mac. And when I talk about patching applications, I'm mostly talking about the third-party applications that every end user has on their system, or even most servers. So things like Java, things like Adobe Flash, and there are other ones, i.e., any web browser. Those are things that really are as important, or sometimes even more important, to patch than the operating system itself. In fact, 80% of the vulnerabilities found in the top 50 cybersecurity programs were affected third-party applications such as Flash Player or Reader or Java or Skype or media players and things that weren't part of the operating system. So when end users, or I should say when organizations talk about patching, the ones that take cybersecurity most seriously are ones that treat application patching as seriously as they do operating system patching. And most organizations that I work, they patch on a monthly basis. And for Windows, it centers around Patch Tuesday. So they will have a process where the Patch Tuesday patches are released, and then they will go through a testing process, or a vetting process, if you will, where those patches and any third-party patches that came out that month will be distributed to endpoints within the organization, to what they call a test group. And that typically is folks in IT or virtual systems that are considered part of a test. And then they will launch their day-to-day applications, either custom applications or off-the-shelf applications that are needed to run the business, and make sure that there are no compatibility issues with those patches that were released. And then once those compatibility issues have been highlighted or checked that there aren't any, then those patches will then be distributed to the broader organization to make sure that the machines are patched and are not you don't have vulnerabilities that can be exploited. So that's kind of a primer on patching, but it is a very important and time-consuming process for many organizations. So, but as I said before, it's an important part of cybersecurity and something that needs to be done on a regular basis.